Everybody. In our last video, we were talking about correlations and types of correlations and the magnitude of a correlation and what a correlation means and how to interpret correlations. And we ended with a discussion about the fact that correlation is not causation. We can no way infer just because there's a correlation that one variable caused the change in another variable. Some of the challenges with that assumption we talked about was directionality. We don't know if attendance is causing bad grades or if bad grades are causing poor attendance. Sometimes people do so poorly in math, they stop attending because they're kind of depressed and discouraged. So directionality is a problem. Additionally, there could be some other confounding variable, like there's a correlation between ice cream sales and crime rates. Does that mean ice cream is causing crime? No. The third variable that's confounding that relationship is temperature. Temperature makes people irritable, can cause them to commit more crime, and it also can influence ice cream sales. So that third variable problem is a challenge because there could be some outside variable causing the relationship. And then we ended with illusory correlations, where there are false correlations where people think there's a correlation, but it really doesn't exist. Like people think that in full moons, people behave crazy and more people end up in the ER. And that's not really the case, statistically speaking, but we have this confirmation bias where we look for evidence to support our assumptions. And so it's kind of like when you just bought a new car, like I bought a Honda, you start to see all kinds of that car on the road because it's confirmation bias. You're now looking for something that's already within your thought and purview. So I have a couple of examples of some correlations that have been ripped from the headlines, and I just want to go through these with you so you can see why we cannot assume causation. The following statements have been stripped from the headlines, kind of like Law and Order, and I want you to think about what they're implying and what are some other explanations. So, want a higher GPA? Go to a private college. The implication there is that private college influences your GPA. In fact, it improves your GPA. When in reality, it's not that going to a private college necessarily causes a GPA increase. They actually might already be recruiting people with higher GPA, so it's a selection bias. It's a sample bias. Additionally, maybe people who can afford to go to private college have more money, so they buy their grades. Or maybe the professors feel more obligated to them because they are paying a higher tuition. Loud bar equals more beer. Does the volume of the bar directly impact beer sales? Probably not, but that's the implication, that louder bars are causing more beer. And that's presumably more beer consumption or more beer sales. And because there's a relationship between those two things. In reality, increased beer sales might be causing the volume to increase because people are louder and more obnoxious, or I tend to be a little more friendly, let's say, when I've had some beers. A little too friendly. That's what got me in my last relationship. Okay, higher beer prices cut gonorrhea rates. So it's implying a relationship between beer prices and gonorrhea rates. It's implying a negative correlation because it's saying that higher beer prices have lower gonorrhea rates. Is it really the beer price that's causing gonorrhea? No, it's definitely a microbial that causes gonorrhea. But maybe beer prices mean less beer sales, and when you're not selling as much beer, you're not drinking as much beer, and when you're not drinking as much beer, you're not ending up in bed with people you shouldn't be ending up in bed with, or you're less risky in the people you do choose to end up in bed with, and so you have less exposure to gonorrhea. But there's some other confounding issues that are actually explaining the relationship. And then finally, don't be a Super Bowl statistic. Stress of watching the big game can be hazardous to your health. The implication there is watching the Super Bowl is bad for your health, but it's probably not watching the Super Bowl. It's all the other confounding issues. Do I have money on it? Am I gambling? Am I betting on the game? What am I eating while I'm watching the game? Maybe people who watch the Super Bowl are more likely to eat junk food, and that is causing the heart issues. So there's other underlying factors. So since we can't infer causation from correlations, let's look at experiments which do allow us to test cause and effect. Experiments are the most powerful research method. They're the only way we can test cause and effect. They start with a hypothesis, and we talked about that earlier, where a hypothesis is a testable prediction about the outcome. We can test it through direct observation, we can carefully review the research, and we can determine if we were correct or incorrect in our prediction. When we design an experiment, we have to have a control group and an experimental group. So there's two separate groups. A control group is kind of protected, and they're our comparison group, and our experimental group is our exposed group. So they're exposed to the treatment or exposed to the drug, or they're exposed to our independent variable. The control group is not exposed, they're our comparison group. So let's say we're looking at the effect of a soda on behavior, and the control group doesn't get the soda, and let's say it's an energy drink, and the experimental group does get the energy drink. And so we're looking at these guys are compared to these guys. These guys were exposed to the treatment variable, or the treatment, which in our case is an energy drink. So an experiment's a carefully controlled procedure. It has clearly defined operational definitions which tell us specifically how we're going to observe and measure our variable, such as if I am saying I want to study aggression, I have to very clearly define what constitutes aggression. Is it hitting, kicking, biting, punching, screaming? Maybe for some it's name calling. Maybe for some it includes excluding someone from a group or starting rumors about someone. That's relational aggression. So I'm going to clearly define as a researcher how I want to study aggression. I'm also going to include some methods to control against participant and experimenter bias. I want to have a systematic procedure where both groups are treated as equally as possible. I might have, a random sample. I want to make sure my sample is representative. I randomly pick my sample. I just don't go through an arbitrary and systematically pick people that I want in my study. I need to randomly let everybody have a chance to participate. It should be cross-cultural, so I should have people from all the different ethnic groups represented. I want to make sure that I have like a script that I'm using so everybody's treated the same way, and I'm not being really mean to one group and nice to another group that might influence their irritability and aggression. I can use a blind and double-blind procedure. In a blind procedure, the participants don't know what group they're in, so maybe I'm going to have them watch a video, and then I'm going to have one video violent and one video not violent, and then I'm going to measure their aggression on the playground. And for my control group, they are not exposed to the treatment, so they're exposed to the non-violent video. And then my experimental group gets my violent video. In a blind study, they don't know which group they're in. You know, this isn't a great example. Let's say they're getting a drug. They might have a placebo. In a double-blind study, they don't know, and doubly so, I don't know. So both the researcher and the participant don't know. And that helps to eliminate any bias, because I'm not going to treat you differently because I don't know what group you're in, so I can't systematically influence the results. When we are talking about drug studies, and we say the control group gets a placebo, we do that because just the very fact that you're taking a drug, there's certain expectations that you have and benefits you expect to gain from that. And so taking a drug itself, the process of taking it, not even just the drug, but the process of taking it can benefit you. And that's what we call a placebo effect. Even if you're taking a sugar pill, because you took something, you think it's going to help you, and so you do automatically start to get better. So when your control group is not supposed to get the drug, instead you give them a placebo. And then that's just a sugar pill. So it's completely it has no effect on you. And then the experimental group gets the actual drug. And they both get some benefit just from taking a drug and thinking that they're taking a drug. But that evens them out. And then the rest of the change in behavior will be because of the drug itself. Again, we want diversity in our sample and our researchers. And our researchers are important because that prevents me from interpreting the results from my biased perspective. It helps me protect against ethnocentrism, where I interpret things through American eyes and I assume things happen because of a certain way that's common in American culture, but maybe a cross-cultural researcher might present a different viewpoint that is actually very relevant to that particular culture. And then again, the experimenter is going to control and manipulate the variables, and they're going to examine how one variable might cause a change in another variable. So we're looking at the treatment variable or the drug causing a change in the behavior. And sometimes when we want to study something, a variable, sometimes it can't be ethically examined through an experiment. I can't control and manipulate, let's say, gender, and I want to study gender differences in self-esteem. Or I can't manipulate child abuse and who gets abused and who doesn't. And so when there's a variable that I want to study and I want to compare groups, I can use a quasi-experimental design where my variable is quasi-experimental. In other words, I'm comparing men and women, but I don't get to control and manipulate gender directly as the researcher. When we're talking about participants for an experiment, first of all, what we call our participants are, in fact, who we're studying in our research. And a lot of historical research has been done on college students, and college students may be very distinct. And so a lot of our historical research may not be very representative of the general population. It's better to take a random sample, and we want to take a subset of the larger population, and every member of the population of the sample should have an equal, or excuse me, every member of the population should have an equal opportunity to be in our sample. In other words, I'm not just selectively putting together a group that I just kind of flip a coin to decide who's in my group or not, or I just throw out a big giant net and whoever randomly comes into my group comes. And when you have a representative and a random sample, it's usually more representative. In other words, when people come to you randomly, they're more likely to come from all backgrounds, as opposed to you personally selecting. Additionally, random assignment is really critical. Remember when I said we have a control group and an experimental group? How they get assigned to those groups should be random. Every person should have an equal chance of being assigned to either the control or experimental group. I don't put all the smart people in my experimental group and all the not so smart people in my control group, or all the hyper people in my experimental group and the not so hyper people in my control group. I want to make sure that they're randomly assigned so those can be evenly distributed. I'm going to have just as much chance of all smart people in my control and just as much chance of smart people in my experimental, so they'll balance each other out. And I do random assignment by flipping a coin, literally, with each participant saying control experimental, and the law of large numbers says those will balance out. You can use a random assignment tool that are often available through the internet as well. So I'm going to stop here, and I'm going to come back in the next video and wrap up our discussions of experiments and research methods so that you can go on and finish out the chapter. Okay, I'll look forward to seeing you in a bit.